Okay, so we just talked about how if your correlation coefficient has been proven to be significant, we could actually come up with a regression line. We have all these different data points, and technically we did a table like this, right? And we could figure out what our regression line is, what the equation of that regression line is, right? Now, like I always say, whenever I can, I want to show you all how you can figure it out with your calculator. So you don't have to do this. This is beautiful and it's math, but if you happen to have the ability to have this calculator, and I say this calculator, there's others. Obviously, this is the one that I love because I'm used to it. I actually think this is when I was getting maybe my bachelor's degree. I had my calculators for a long time, and these are the ones I love, right? So, say you entered in stat, edit. Remember how we entered all this in? I did that to figure out the correlation coefficient, but you do the same thing if you want to do your 9.2 homework, right? And we want to figure out that equation of the line. So I would enter in my x values, enter in my y values. I'd second mode to go home. I think you could hit stat again, y'all. I second mode it all the time. Second mode, we want to calculate. You do the fourth option, which is the linear regression option, and you want your x variable to be with your a. That a is actually your m, okay? When you hit enter, enter. Okay, see how it says y equals ax plus b? That is y hat equals mx plus b. Our a is our m, okay? And it's 0.1775, and you see how it is, it's actually like more decimals than we need. It would tell you where to round your m and your b. Because that's 4 places, you would round that 4 places, which down here, I'll text you right there. We did that, right? There's my finger, right there. And then the b, that is your b. So you would do y equals, that a is your m, write down that x variable. That x variable allows you to plug in other data points so that you could use this line of best fit to predict what their x value will be, which is the whole section, right? And then our b ends up being the 1.8052, but obviously like you round it. Okay, so I think everything's good. Now I'm just going to turn that off. Okay, I still just got really concerned about our being a 4. Okay, we're just gonna use this calculator to figure out your m and your b, okay? If you don't have to do it by hand, use this. Use the value that you get here. If you do it by hand, you could accidentally make like a really small mistake, and that's, y'all, I'm acting weird because I want to recalculate this. On my calculator, did y'all see where it was stat over 4? Can y'all see me? My B is 1.8052. When I did it right here, I got 1.8054. I actually want to use the value that ends in 2. Okay, I'm going to recalculate this just a little b on this next page, but I'm going to do it kind of line by line by line instead of entering it all into my calculator, okay, because I want it to be as accurate as possible. And ending in 4 is not the same as ending in 2. You enter this into the my math lab, it's going to tell you you're wrong. Okay, so I want to just take a little bit more time calculating this y-intercept, so that moving forward with this example, we're using what this is saying, which is it ending in 2, like once it's rounded. Okay, so we're going to do that. To find our b, I can't spell. Okay, and this is kind of just for continuity. I want what I have on the paper to match what my calculator says. I want there to be similarities between what we have. Our b is the mean of our y values, subtract from that slope times the mean of our x values. Okay, and remember they broke that down to say that if you take the sum of your y's and you divide it by the number of data points, and subtract from that your slope multiplied by the sum of your x values divided by the number of data points. Y'all, the ones who just looked in, whenever we did this and I kind of entered everything into the calculator, I ended, like it rounded to the 10,000th place, whatever it is, with a 4. Whenever I showed them just now how to get your M and your B with your calculator, it ends in a 2. So I don't want to just enter it all into my calculator. I kind of want to do it like piece by piece a little bit. Hopefully you have this calculator and you don't have to worry about this recalculation. But I'm doing this mainly for the ones that don't have this calculator, okay? Well, let me have this stuff in front of me. So my B is going to be equal to, I'm going to use this right here, the sum of my y's, which was 17.4 divided by 6. And I subtract from that my M, and I'm multiplying it to the sum of my x values divided by the number of data points. I'm actually just going to go and enter this little fraction into my calculator to kind of do it step by step, just to show that I don't know what I did wrong. It could have been something, but 17.4 divided by 6. B is equal to 2.9 minus, and then 0.1775, open parentheses, 37 divided by 6. Did I get that right whenever I did that on paper by myself? By myself. Yes. Okay, and I did kind of round it slightly. Did you call her? Yes, I did. Left a message. I got 1.09458 is kind of where I rounded it on my paper. I know that ultimately they want me to round my B to 4 decimal places, so while I'm working on this like step by step, I keep this a little bit more than 4 decimal places just to ensure that it's accurate. If you enter this into your calculator, 2.9 minus 1.09458, do you see how I got 4 again? What is happening? Let me do this instead. Don't do that part. Let me actually just take the 2.9 and I'm going to subtract, I'm going to grab that whole thing. I'm going to highlight it. Y'all might not be able to see it, but it's being highlighted in blue right now, and I hit enter. Do you see how it just pasted that whole entire thing, not rounding it anywhere? And then if I hit enter again, I don't know what's happening. I don't know what's happening. It sucks because I don't know how to explain what the difference is. This is y hat, right? The 0.1775x, you plug it in the x's that they give you, plus, and it ends in a 2. So we keep getting 4. I'm gonna do the example with 4. If y'all run into an issue with your homework, you just let me know, but we just did it 3 different ways and I got 4 each time, okay? 0.8054, which is the same, okay, as what we got on the previous page. So that could have all just been for naught. I'll ask somebody why what I'm calculating is slightly different than what the actual calculation is. Ooh, let me check my data points. Stat, calculate. Is it 2, 8, 12, 6, 4, 5? 2, 8, 12, 6, 4, 5 for my x's? Yeah. Okay, 2.1, 3, 2, 3, 9, 3, 2, 5, 2, 7? Yeah. Okay, so, I don't know, I'll ask. I mean, I could have gone through all of this without having the recording on, but it's fine. Like, we dug a little bit deeper, we tried to figure it out. Another reason for why I would urge using the calculator, because then maybe you don't make those mistakes by hand. Okay, so now what we're going to do is we're going to sketch the regression line with 2 values of the x's that they give us, right?
Did you get 2?
When I used the calculator. When did you get 2?
It's 1.805.
I know, that's what I keep getting. Let me go home. I keep getting 4 over and over and over again. Let me do this. Let me do 37 divided by 6. Okay, so that would be 0.1775 times this. And then that would be 2.9 minus this. So I'm not rounding anything. Okay, like I did the 37 divided by 6, which gave me a big there. I'm not rounding anything anywhere. And I should get the 2. I get a 4 again.
So when I calculate it, I get the 4. But when I do the stat,
that's what I say to use. This is obviously me showing you how to do everything by hand. I want to move forward with this example using the 2 because with the data points that we have in our X and our Y, when you go to calculate option 4, this has got to be more accurate than what we're doing, and it's 1.8052. Madeline, do you see that whenever you calculate it? Are you getting the 2 here? I want to use that. Okay. I mean, this will haunt me until I go to my office and figure out maybe like one little tiny thing that I'm not doing right. So we're going to use what our calculator gave us because obviously it's going to be a little more accurate than what we just did by hand because I'm not getting the same thing. So now what we're going to do using y hat is equal to 0.1775x plus 1.8052. No, well, it's using the same thing. So this was like, I actually took data, talked to students, got the number of hours and the GPA. Now it's like moving forward. If I just talked to you and you said, hey, I study 6 hours a week, we could use this data and this model technically to be like, hey, I could actually go in and predict what your GPA should be. And that's kind of what this is right here. So using what we just did with that example, we're going to sketch the regression line. This right here is very similar to how they have you do it on the homework. After this, I do have one like homework example. You sketch regression line with the given x values. Yeah, I hate sketching, but we're going to do it. Calculate the corresponding predicted y values. It said sketch, so we're going to use 2 points, and we're going to actually sketch a line through those 2 points. I might not actually sketch the line though because they never really look the same. On the homework, you're given an X, you calculate the Y. You're given an X, you calculate the Y. You'll plot both of those points on the little graph, and then you'll pick up the line and you put the line through those points. Okay, that's not as easy to do on paper. Okay, so what we're going to do is we're going to let x equal 6. What this is saying is the student studies 6 hours a week. So you go back to, right, using this equation of this line. If we're going to calculate what our predicted y value is, where we see x, we plug in what they said to let x equal. And here x is 6, so we're going to calculate this. Plus 1.8052. And yes, with your calculator, you could type all of that in. You could type all of that in the exact way that we see it with those parentheses, and it'll actually give you your y. Okay? And so, y'all check me, because, I mean, apparently today's not my day. I have a y hat value, right, the predicted y value. It's 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. 2.8702. My understanding, because in our data, our Y value for our GPAs, it was all to the 10th, right? 3.0 or 2.9 or 2.1. So what we're going to do with this predicted value is we're also going to round it to the 10th, to the 10th place. And remember, the first thing right here is the 10th place. You look at the number next to it to see, do I stay or do I add 1? 7 would tell me to add 1. And I add 1 to what I underlined. So this is telling me that the predicted Y value is actually 2.9. And so if the homework tells you that you're going to be graphing it or plotting it, right, drawing a line through these points, this would be a coordinated value of X being 6 and Y being 2.9. This is saying that I'm predicting that if you study 6 hours per week, your GPA should be 2.9. Based off of the data that I gathered from the previous students that I surveyed, and the reason why we found this line to begin with, okay? Now, you can't draw a line through these data points unless you have 2 coordinated pairs. That was one of them. Now what we're going to do is let X equal 8. Do the same thing, figure out what that point is. And y'all check me too, with your math. We use our predicted Y value, that equation of a line, the regression line, which is 0.1775 open, place 8, where X was. Madeline, that's why we keep the X, right? Whenever we wrote what the equation was, because we should be able to use it to predict things later. And if it wasn't anything, we would actually just add those up and you'd have some random one numerical value. We want it to stay as an equation, so it's a line. And then we add to it 1.8052. I'm going to go and do this one, clear. Do 0.1775 open 8 close plus 1.8052. And if you notice, I get 3.2252. Okay, if you want to do the multiplication first and write it down and then do the addition, you can. But there are things that you can just enter right into your calculator. So here what I get for my predicted Y value is 3.2252. But when I look at my data is round to the 10th place. So I'm going to round this to the 10th place. Yeah. That's letting X equal 8. And this is so that I have 2 coordinated pairs so that I can actually sketch this graph. On the homework, you don't really sketching it, right? Like you're plotting the points and then you're going to pick up that line and put it through that line. Put it through those points, sorry. So I look here. 2 tells me to stay. So this is saying that when X is 8, my predicted Y value is 3.2. And do you remember how my correlation coefficient, the previous chunk that we just did, was strong? That was saying that there was a strong correlation in the data, which would also be saying the more you study, the higher your GPA is. Do you see what that's technically what that would be saying? Okay, because it's a strong correlation. So the more you study, your GPA goes up. Okay. I have a note here that, we do need to have 2 points to draw a line, which hopefully that does make sense. And then, like I said, in your homework, you would click on the graph, and I believe you have a cursor. You would go over 8, or let's do 6. You'd go over 6, right? 1, 2, 3, 4, 5, 6. That's positive, so you'd go up to 2.9, and you'd place a dot or a point. And you do it again here, and then you put that line straight through both of them by touching those points again. Okay, that screen is insane. Does that make sense, y'all? Okay, so this one right here, the last thing that we're going to do for 9.2, I wanted to actually have a homework problem written out the way that it's kind of formatted on my math lab, just so it made more sense. What we did now was like slowly kind of build to an example. Okay, now I'm just going to do like a homework problem, and then we will be done with 9.2. We're going to actually start 3.1 and just get as far as we can. And it's crazy because I think moving forward, my chapter 9s are going to go somewhere else, because I don't particularly think that linear regression and correlation coefficients need to go with probability. And that's actually what chapter 3 is. We're going to do 4 sections of probability, and this was like a complete different train of thought. But that's neither here nor there. I just know I don't like it there. Okay, homework example. Okay, so find the equation of the regression line. Construct, and we're not actually going to do this one little direction right here. I did just literally paste in my own handwriting everything from a homework problem. It says to construct a scatter plot. So on the homework, you would open up the graph and you would be placing all of the different data points that they give you. Okay, and I'm going to show you kind of how to do it, but we're not going to actually create one per se. Construct scatter plot. Comma, draw regression line. You know, I expect y'all to look at your homework today after doing this, since we finished it in its entirety. And if you run across like the homework asking for something or it being confusing on how to do it, like, I need an email, because I don't do y'all's homework, so I need to know what y'all see. Okay, I don't know what y'all see. And predict the value of y for each x value. So, we've been doing columns, right? Like whenever we do our data or whenever I've shown it to you, and I noticed that what they do is they have 2 rows and then like all these little bitty columns. So they have like height is our x values, and underneath that, y'all, stories. So it looks like here they're comparing the height of buildings and how many stories that building has. Maybe the more stories you have, the more height your building has, obviously, but that's kind of what it is. And then I just did like a vertical bar. And then I'm going to list 1, 2, 3, 4, 5, 6 different data points going to the right. I'm going to start with the height of, I'm going to switch colors just because. The first building has a height of 768. We're going to assume feet. And this building actually has 51 stories. You kind of see how they're showing it. I'm putting a black bar underneath just to keep myself from having to draw a really uneven line at the end. And then the second building is 629 feet tall, and it actually has 47 stories inside of that building. Third, 518 with 43 stories. 509 with 40. I have a building that's 496 feet tall that has 37 stories. And then lastly, I have a building that is 477 feet tall containing 34 stories. Make sense? Okay. So it's not columns now. The way we would do all of our x's here and have one column, all of our y's here, right? We've got x's and y's in each individual column. Okay, so the first thing that I notice is they give me, do you see where it says draw a regression line and predict the value of y for each x value, right? What they did is they're going to give me 4 x values, and I'm going to predict it for all 4 of those values. So I'm going to do my x values that I'm predicting in this pink. The first one that they tell me to predict and do is where x is equal to 500 feet. Predict about how many stories are inside of this building when x equals 500 feet. B, we're going to predict when our building is 643 feet tall. C is when our building is 812 feet tall. D is when x is 726 6 feet tall. Okay. So, what you can avoid doing is that whole table that we did previously when I was really just slowly building up how to solve the problems, right? Because all I have to do with this calculator is enter my x's in list 1, my y's in list 2, and then stat, calculate, option 4, enter, 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 enter. That's my regression line. Do you see what I mean? And you're done. You've got that entered. Just be careful, because this isn't like x1, y1, x2, y, like no. All your x values are the first row, okay? So I'm going to kind of cover it up a little bit as far as the hyphen thing here. I'm going to clear just because it's a habit. I'm going to stat, edit. I need to go over and highlight L1 so that I can hit the clear button and hit enter. It just takes away those data points that I was previously working with, okay? Here what I do is I type in my first x value, which is 768. What is my second x value? And then 518, 509, 496, 477. I go over to the right, and now I do my y values. 51, 47, 43, 40, 37, 34. Make sure they're even. I do it all the time. I'll get out, I get errors, I'm so confused. It's because I left something off. Okay. Now after you've done this, I want to hit stat again. Go over to calculate and do the fourth option and a whole bunch of enters. That is my regression line right there. That's the data that I need, okay? If you want to do the x and the y and square it and then do that and then sum it and, I don't know, bonus points maybe? Okay, so my y hat, my regression line, is what? Oh, I didn't write it on here. We can add it right here, y'all. Round slope 3 and y-intercept to 2. Okay, so right here. Sorry about that. Round slope 3 decimal places and y-intercept 2 decimal places. It'll always tell you that. If it doesn't, then yeah, it wants all like 10 of those, but that's very, very, very unlikely. Okay. That was a little direction that I did forget to write there. So if I have my slope being rounded 3 decimal places and I have 0.05 and it goes 1, 6. 1 is in the 3rd place, so I look next door, which is the 6. That 6 says to round up, which makes the 1 become a 2. Okay, if that doesn't make sense, y'all need to make sure that y'all let me know, okay? Do not forget your variable. Your variable is what allows you to predict your other values. And then we have plus. And then it told me to round my y-intercept 2 decimal places. I have 12.762. That 3rd value of 2 means stay. That 6 stays a 6. So 12.76. That's my regression line. Do you see how that's a lot easier than sitting there doing that whole table? Yeah. Okay. So that is the regression line or the equation of the line, whatever type of word you want to put there. Now, as far as construct a scatter plot, I believe a 6. Just a very weird, homely looking 6. It's sad. What's it called? I'm trying to remember. I sleep and then I forget things. I'm like Dory. I think it might ask for a list of the ordered pairs needed for a scatter plot, because it might be the reason why I have a list of ordered pairs right here. I'm going to just put ordered pairs for scatter plot, and then we're just going to list them. The only thing that I could be leaving out would be it might actually want you to plot all of these little points. That's the only thing that I'm not for sure, like I'm not remembering it exactly. Okay, so let's write here, ordered pairs for scatter plot. Ordered pairs are in the format of what? In it like open, X, comma, Y, close, right? Look at this. This is an X, Y coordinated pair. This is an X, Y coordinated pair. This is you have 6 of them, okay? So I opened 7, 6, 8, comma, 5, 1, close. If you are entering these and it wants the list of the ordered pairs, you have to put a comma in between all of the individual pairs. Next, I would do open 6, 2, 9, comma, 4, 7, close, comma. Okay, you can't do like the parentheses being back to back to each other. Okay, it'll tell you that that's not correct. My next ordered pair, 518. I don't know why I tried to do an apostrophe. That is definitely not explicit. It's not that big or defined, so I'm just gonna not dig for my whiteout. 518 gets paired with 43, close, comma. Kind of ran out of room, so I'm gonna start a second row, okay? My fourth coordinated pair would be 509, comma, 40, close, comma, open. 496, comma, 37, close, comma, open. 477, comma, 34, close. You don't end it with a period or anything, okay? You just don't have to do another comma because there's no more. That should suffice, okay? Again, if that's not what they're looking for, then they want you to actually open up the graph and plot of those. But if you're looking at this and you need to do this to know what points to plot, then that should help, okay? Now what we're gonna do is A, B, C, and D. And then that ends 9.2, okay? I'm gonna kind of switch to my pinkish color since you're now doing the work for those pink directions. So, for A, it's very similar to that previous page we just did, right? We had those data points and then it said let X equal 6, let X equal 8, right? On my piece of paper, I'm now gonna let X equal what? Yeah, so I'm gonna say let X equal 500, and then, you know, here's where I do my work. What does that mean? That means that I have y hat equal to 0.052 open, 500 close, plus 12.76. Enter that into your calculator. Enter it all into your calculator if you can, and that makes sense, because then in a minute when we do the next one, all we have to do is just change the x's each time. So I would clear my calculator just to make sure nothing is inside of it. Okay. And then I would do 0.052 open, 500 close, plus 12.76, and I hit enter. Okay. So what I get is the predicted, right, the X was the square, well, not the square feet, I'm sorry, the feet of the building. It's saying that if your building's 500 square feet, I could predict that there's a 300, why'd I say 300? 38 point, y'all get 76. I don't know why I said 300. But look at your data, right? Your stories, all of them were whole numbers. So I'll round this to a whole number, right? So it would be 39. Yes. Plus, I mean, we're talking about actual stories. We wouldn't say that we have 0.76 of a story, right? So I do need to round this. The same way that we did previously. And we matched like the way that our X was set up. Okay, that should be. I just said round to whole, but my hand like did not lift the whole time I wrote that. It says round to whole. Might not look like that though. Okay, so when I round that to 39, I can go ahead and put this into my, what's it call it, right? Like this is a coordinated pair, but it allows me to see. This is saying when X is 500, Y is 39. And I'm so sorry, because I don't remember exactly what they want on there. I think they might just ask for Y, right? And they would want the 39. Or they might show you X equal this, and then you plug in the Y. I don't remember. It was like 2 o'clock in the morning. Okay. Now let's do B. Here we will let x equal 643. Everything's the same, except for whenever I open my parentheses next to my slope, instead of 500, I write 643. Do you see how we already have this in our calculator right here? Right? So you can not really tell what I'm doing, but I have the original that I first typed highlighted. If I hit enter, it pastes it to allow me to work on it. If you scooch over and you highlight that 5, I can do 643. And now I've just replaced 500 with 643. Or you can retype all of it. Okay, that's just like a little shortcut. And what I end up getting for the value of my predicted y is 46.196. What does that round to?
46.
Yep. So this is saying when my building is 643 feet tall, there's approximately 46 stories. I kind of hate having to do this, but I will need to change pages to do C and D. Okay. Good. Okay. Okay, for C, we're going to let x equal 812. I feel like this one they're trying to trick you, okay? Because you start doing all of this work, and then you notice that if you really look at the data that they give you, what is the highest data point that I've been given? 768. So I can predict y values for x values that are in my range. The range here, the data that I have, is 477 feet to 768 feet. That's the range of data, right? I can predict stories for buildings 478 up to 768, but I can't go past that, okay? And so you would actually say not in range. I don't remember how you answer it, but we would see here that our data range does not include this number. I know this is not technical, I wrote y hat equals no. And then I said not in range. So maybe there's going to be some kind of option, you know what I mean? Like two little bubbles. One, you would select it and put the stories. The other one would say X is not in range, so can't predict the Y. It's going to be something similar to that, okay? And then our D, we will let X equal 726. I'm a little gun shy after doing C. I look back at my data. Yes, 726 is within the range. I can't actually calculate this. I have y hat is equal to 0.052 open 726 close plus 12.76. I get a predicted value of, I actually just have the answer. Let me split it into here. I just have 51. I don't know if it needed to be rounded or not. Sorry, I typed the wrong number. I did 625, 726. Yeah, okay, so I get 50.512. I need to round this. I round to the whole numbers. That would mean look at your, I'm so sorry, I'm rounding here. So I look at my 10th place. That 5 means to add 1. So my predicted value becomes 51. This would be saying when my X is 26, when my building is 726 feet tall, I'm predicting that there's 51 stories in that building. That makes sense, y'all? Boom. We are done with 9.2. Okay.